This is recorded. Figuring this out as we go. I myself have been with Tredence for almost 4 months. I run our talent acquisition here at Tredence. And Jason, I turn it over to you.
Hi, welcome everyone. So my name is Jason and I am the data architect in Tredence. And I want to welcome every one of you to be here today. And this is our Tredence first hackathon, and our goal is to hire some of the talented people on this call. And if you have any friends that you want to join, this hackathon is open, and we will be having fun in the next couple of weeks. And then at the end of the 2 weeks, we will have a presentation, and hopefully we'll hire some of these talented folks here. And remember, we have prizes as well. So we have cash that you can bring it home if you win a hackathon. So even if you decide to block the joy challenge, you still can take the cash, right? First of all, do you want to ask if anybody has any questions before we kick this off?
Any glaring questions or concerns? You don't have to ask. If questions come to you throughout this process, this is not your only moment to ask. We are here to answer your questions throughout the process.
Also, Jason and Heather, Sunana here from HackerEarth. I just want to let the participants know that the chat window is open for anybody who has questions, right? I think we have a question already from Ayush. So
yeah, you can just pick one of them. And if you wanted to, you don't have to finalize it today. So today what we're going to do is I'm going to go through the 3 problems, and after that you can pick one of them. But if you feel like midway you wanted to change, feel free to change, and we will pick the highest score from your submission. So as long as you feel like you have enough time to finish the problem, so please feel free to pick one of them and change in the middle, or do whatever you want to do. Or you can just do all 3 of them if you really enjoy doing it. Any more questions? Yeah, you could use AutoML, but you can use whatever way you want to use, but ultimately your submission, you will need to submit your code. So you use AutoML as your baseline, but then you will have to build your code after you finish. Like after you get your baseline, you have to submit your code to us, and it cannot be an AutoML. So you can use that just to cover, just like as something to start with, right? So so the evaluation criteria and matrices, they are on the hackathon website, and I am going to show you the website. I'm going to go do a walkthrough of the hackathon website and the dataset petition, and hopefully after that you will get all your answer. So if there's no other questions, I am going to share my screen, And so hopefully everybody is already registered on this hackathon page. And so here we have, so to begin with that, like, I think this part of the site, the web page is more relevant to everybody now, that you may submit as many times as you like, and only file submission will be judged. So you only have to choose one project, and so, but at the end of that, you need to submit your code. Just link to your GitHub or upload it, and you need to do a presentation to explain your methodology. So, and then just basically we will at the end of the presentation of the hackathon, we will have some of the our leaders in the data science in Children's to be the judge panel. So then you have to present to them your methodology that was used, and if you manage to get on maybe top 10 of the leaderboard, we will invite you for a presentation. And so to begin with, I have also provided some resources here. So they are just like some of these more relevant to the hackathon that you can use to sharpen your skills in machine. You can take a look at this. They are log judged, so you can spend time to, for example, practice some Python questions. So HackerEarth has provided some questions for you to sharpen up your Python, and you can solve these questions and using Python. That will just like hopefully sharpen your mind if you're not very familiar with Python. And you can do these things on your own or don't do that. It's really up to you. They are not judged, they are not scored, but it's really for you to kind of warm up yourself, your skill set in Python. So I've also included some of these links that I think is helpful and related to the questions that I can come up with. So these are the like some of the, if you already know the like the deep learning or stuff, some of these things, you can skip this, and by all means this is the answer.
Jason,
So
we just lost your screen.
Oh, okay.
Or at least I did.
Let me share again.
Perfect.
Are you still seeing the screen?
Yes, we can see your screen.
Okay. Let me go back. So you're seeing this website right now?
Yep, thank you.
All right. So this is just the kind of the some of the guideline that I think it helps for some of the beginners, and because we don't know your skill set, and so that's why we put some of these resources here, and you can go through them if you feel like you need to, and these are not the answer, but they will help you to get to the answers. And as far as like computation, so that's also a course here by Google. If you're not familiar with machine learning, I highly recommend you to go through this course. It's very comprehensive, and if you're able to understand everything here, I'm sure you will do well in this hackathon. So, and everything here is free of charge. You don't have to pay anything. And Jason doesn't receive any credit for if you join or don't join. So it's like it's really self-paced courses, and these are the resources that I personally found helpful. That's why I put them here. And finally, there's a couple of platforms if you need it. So there's no restrictions. or whether you do it on your laptop or you go rent like very high performance server that you pay like a lot of money to train a model. So there's no restriction. But if you are looking for some quick and free resources that is also happen to be very performant, then I suggest you to go use this Google Colab or the paper space gradient. So it's not a requirement. No, it's not a mandatory to solve 3 questions. Just one of them is enough. So that's a Google Colab and paper space gradient. So I'll just do a walkthrough on Google Colab and tell you what it is. And so Google Colab is a free kind of Jupyter notebook provided by Google that you can use it for your machine learning projects. So everybody should have a Gmail account. If you don't, you can just go to gmail.com and sign up for one, and it's free of charge as well. So so what you need to do is just go to colab.research.google.com, and then you will be able to log in using your Gmail account, and then you will be able to you just click sign in, and you will be able to log into an environment, and you will get to this like introduction, and you can go through the introduction. Just like if you have used Jupyter Notebook, you will be able to understand what it's doing here. So just for example, you can just hit the run button here, or you can just go run time and just hit the run all, whatever you want to do. So you can connect over here. So once you connect it, it takes a few seconds to connect. So now it's connected, and you can run your your notebook here. So you can train a deep learning model, a machine learning model in Google Colab. And so some of our children's kind of college graduate who we recently hired from college. I was just right out of college, just maybe just 1 year older than many of you, or 2 years older, and they have low background in data science, and they were able to use Google Colab to train some deep learning model. So then that would be a little bit of learning curve if you haven't done this, but it's doable in the time frame that they are provided. So that's for the computation environment. So Google Colab or paper space gradient, those are the choices that you can use to do your deep learning model or machine learning model. So any questions so far?
Do not hesitate to unmute yourself and ask questions, or of course, utilize the chat function. Reminder, you do not have to do all 3. Pick your favorite, complete one. However, if you start one, and you are welcome to do all 3, but no, just pick your favorite.
So if there's no question, then I will start what I'm going to do is that I will do a walkthrough of the data set. I will do a walkthrough of what kind of questions that you will be trying to answer in this hackathon. So if you go to this hackathon page and you hit start now button, you will enter to this problem page where we have 3 problems. And the first problem is called X-ray lung diseases. And second problem is called US wildfire prediction. And the last one is called retail recommender. So the accuracy, the scoring is going to be mentioned in the problem statement, and we will go through that once we get to the problem statement. Is there an advantage using one problem over the other? Well, I don't think there is any advantage or disadvantage. So we kind of like tested it internally in Chidens, and some people feel like the X-ray is easier because there's images, and then some people feel like the retail recommender is easier because they understand the retail setting. So, and some think that the wildfire might be more relevant because they live in an area that has a lot of wildfire. So it's we want to pick some real life use cases so that everybody can relate to the problem itself. And so then so if I think the only advantage that you get is that if you're really familiar with well this topic, then you will be able to do it easier, right? So you will be able to find more resources and be able to uh, predict the output even using your knowledge. If you, for example, if you live in an area that has wildfire a lot, and then you will be able to tell whether it makes sense to have wildfire in such certain period.
Yeah, all three questions are equal in difficulty. My guess is that each of you will find one easier than the other, and that's kind of the point. That's why there's three. So take a look at all of them and make best decision for yourself. But there is not one that has a higher advantage over the other. Pending your background and your knowledge that you bring to the exercise. I hope that answers your question.
Yeah, somebody
Thank you, Jason. Please continue.
Somebody asked the question again. Should we just do we have any like QA feature in here that like, because a lot of people are interested in knowing whether they should do 3 teams or 1 team. You can just do one of them. You don't have to do all. So anyway, so let me just start by kicking off the data set, the problem statement. So so first of all, I want to tell you that like a lot of these questions, they are open source. I mean, you can find them on the internet. So by no means that I need every one of you to create original work. It's not it's really not it's really not needed to have to create something original. And so I don't mind if you just like find something on the internet and just put it together. But the thing is that if you get high accuracy, and you will have to present your work to the senior management at Chilens. And so we want you to understand what it is, what you are doing, not just give us a bunch of answers. It's just like doing a very good book report, right? So if you read a book, I would rather for you to read a good book, and and I don't need you to write a book. You just need to read a good book and tell me how good the book is and things like that. So then just like a really good 2-week learning process for every one of you. So here's the first question. This chest X-ray lung image disease detection. The lung image. So what happened is that we have some real life chest X-ray. I don't have so these are the chest X-ray data set, and so I'll just give you some visualization of what it is. So I provided you with a bunch of X-ray data sets. So you have here you have 1,700 chest X-ray images. So these X-ray images, they are labeled, and so so I want you to tell me. So they are labeled as cardiomegaly or low funding. So basically, in each of the file name, in each of the file, you will see the in the training data, you will see that whether it's a cardiomegaly or low funding. So we tell you the disease. You don't have to be a radiologist to understand it. So basically, like you'll see this image, and then this image will have a label along and say that this is cardiomegaly or low funding. And then I will give you 437 of the images that you can. These are the basically the test set. So we want you to answer them to tell me using your model to tell me what all these 443 images are, whether they are cardiomegaly or they are not. So a lot of people ask about the evaluation metrics, and so we use this called the F1 score, and I think there's like this page, I think is very well explained on the evaluation criteria. So I suggest like every one of you, if you want to find out more about the like different kind of machine learning metrics, you can go to this page and take a good look at the calculation and definition. I'm not going to explain anything here. And this, if you go through this page, and you will see that like there's only two of them, F1 score and R2 score that we are using. So here's a calculation for the F1 score, your actual and your predicted. So the actual is the answer that we have, and the predicted is your answer. So we are evaluating your answer versus our answer, and then we compute this is called F1 score. And for the formula and everything, please refer to this page I sent, and you can click on calculation here. You will be able to see that, like, here's how the F1 score is calculated. So I have examples and things like that. So so this is called the F1 score. So once you submit your score, we'll have a leaderboard here. So the leaderboard actually will tell you the score. Who has the latest score will show up here. So then everything will be clear of like whether you succeeded or not succeeded on this attempt. So and what you can also do is that once you have your model, right? So we have 1,700 images, and you can take out 500 of them from your training set, and then you can go back to your use a model and to see how many of them, and then fit it in the F1 score formula and see what your score is before you actually submit it to the hackathon. But there is no limit for you to submit any score. So you can just submit as many times as you want. There's no limit for that. So don't be shy on submitting. So you don't have to wait until you're ready to submit. So only the highest score will be taken into consideration. But also, of course, remember once you get the highest score, either by training a very good model or just simply throwing a dice or simply mark them as all 0 or all 1 or something like that, you will eventually you have to explain your approach to in a presentation. So then you got to understand what you're doing here, right? So that's the accuracy itself is important for us to understand your how you were doing in the hackathon, but the understanding itself is what we are looking for eventually, right? So that's the ultimate goal. Even if you don't get a good accuracy, but you really want to improve your model, you can, once you have the understanding, you can still do that, right? So here, if you download the dataset, this is the download dataset here. So once if you hit this button, you'll be able to download the dataset. And once you download the dataset, so it actually asks you to download it here because we have some images. So that's why we point you to the AWS location to download the dataset. So you will be able to download the images. And then once you have the result available, you will be able to pick the file here and submit it. And then once you pick the file, you can submit it. And then finally you can upload your source file. So any questions on this first question?
So Jason, you mentioned that people can upload multiple times or try different projects. What is the final date of submissions?
The clock has 12 days left here. So you just look at this clock, and so so then once this clock take to 0, everything is 0, then you cannot submit your answer anymore. So that will be your final answer. If you have 1 second left, you can still want to submit, you can submit that. Yeah. But I'm going to do a check-in with all of you next week. If in the case that majority of them, the people are not making good progress, I can consider extending this for a few days because we kind of we're doing this kickoff call on a Wednesday. We started hackathon on Monday. So if you feel like every board majority of people feel like that they need 2 more days, I'm happy to extend it. So, but we'll do a check-in next week. But for now, let's just stick with this time. And if the clock take to the end, then we'll just like call it done.
Thank you for clarifying. Yeah. Also, if anybody wants to join a band, I feel like Jason's kids and family in the background would be eager to join in a band. We can do a hackathon in a band all at the same time. Other questions or clarification or pieces that we can answer for you at this stage? Of course, we're always here to answer questions. As Jason just said, we'll touch base throughout this process and are here to be your advocates throughout.
And just one more thing about this problem. And so this is, as I said, these are the real life problems, real life challenges. And so the actual data set that actually connect 14 different diseases. So I am not a medical expert. I just treat this as names. And so just like when you get to know a new friend, you kind of try to learn their names, that this is similar thing for me as well. So don't feel like frustrated if you don't know what this means. And they are labeled. Of course, I mean they're radiologist already labeled them. And then so the actual data has 14 different diseases, and you feel like that, hey, 2 of them is just like I already get 100% accuracy, slow bringer, or 99.99% accuracy, a slow bringer, cardiomyopathy versus low finding. It's just too easy for me. You can just like contact students and contact us to give you the full data set to work with. So it's like, or you can go to another problem. I mean, some people. So actually, we have a very positive experience with college students and students that they want to continue to work on the problem. So so that's why I'm just saying that this is a real stuff, and you can just like don't be shy to ask for the next challenge if you're bored. Let me see some of the questions. Transfer learning approach. Yes, you can use transfer learning. Yeah, you don't need to decide your model architecture, but there's some tricks in getting a good accuracy. So all these problem statements, they are easy to start with, but they're hard to get really well good score. So use whatever thing you're comfortable with. Just you need to explain your approach. And yeah, so if you do 2 problems and the best out of 2 will be considered yes. You don't have any advantage in solving more than 1 problem. I think I would rather you to get really good at doing something, and then what are you good at doing something, and explain it to the management, because you don't have a lot of time to do a lot of things, right? So then if you feel like that you are already an expert in the problem, I can obviously I can give you something more advanced on this particular problem to work with. So then we will consider you for the final presentation automatically if you are able to tackle the additional challenge. So all right, so I think there was one more question. Oh, why?
The advantage, if you do 2 problems, or if you even do all 3, it'll be the best score. Advantage to solving all 3 would be getting the best score out of all 3, right? If it gets easier or harder along the way, that would, right? The advantage is having more your name out there more, and potentially getting to solve more, or finding a problem that is easier for you for whatever reason. But otherwise, there's no specific advantage. We will not rate those who solved all 3 higher than 1. It'll be highest score. Right, Jason, please
Yeah,
correct me if I'm wrong on that one.
yeah, exactly.
Yeah, so doing all 3 doesn't give you, it'll be just whatever your highest score is. Next question for Jason, where can we find data for extra takeaway?
I think you can just Google them. I think it's so. For the second question, this is more relevant. Like in terms of additional data. The first question is not very relevant for additional data. So I'm going to walk through the second question. So the second question is where you will need, you'll require to find extra data. Um, so what happened is that in this US Wi-Fi prediction, I want you to predict the frequency of Wi-Fi um, occurred between 2011 to 2015. So you can use weather data or satellite data as your features, and we don't provide the satellite data. We have some weather data. And then in your final presentation, you will be required to present your finding in a map visual. So for this dataset description, these are the some of the government websites. So you can find them. That these questions, they you can find the answers online. But what I need is your understanding. So even if you get 100% accuracy, you still need to tell us how you get them, right? So it's not just like, hey, I go 100%, I win, I get the money. No, I mean you come in and you tell me, hey, you download something, you upload the answer, and this is how you get 100%. Then that's not the answer, right? So um, so the file occurring database is in the U.S. government website, U.S. Forest websites, and they have the file occurrences, then cost of Wi-Fi and everything in this data set. And so what I did was that I aggregated the Wi-Fi frequency, and so that you can predict the frequency of Wi-Fi. So how often it will happen if I give you like 1992 to 2010, and then you will predict the rest of the 5 years of data. So so the whole data set has like 1.5 million Wi-Fi's, and then we have the coordinate of the source, and we have the forest name. And so your task will be, the data set I give you is that the shape of the U.S. forest. So using a shape file. So some of you, this in this data set, you probably need to learn some of GIS like system, how to deal with the GIS data. So it will be some learning for everyone as well. So so using this boundary file, you can circle in this called the .cdf file, and then this weather data, they have this in this European Center for Mid-Range Weather Forecasters. They have this weather data, they have historical weather data, where I downloaded them for you, and you need to transform this back into the appropriate like month of the Wi-Fi occurrence, and see the weather in the during that period of time. And then based on the new weather, it's not actually new weather, it's 2021 to 2015 weather. You will want to do a prediction on like whether how often the Wi-Fi occurred. So then if your model is good enough, obviously you will be able to use your model to predict what is going to happen tomorrow or next month or next year. So, but this is not a requirement yet because we already have the data. So we just want you to run your model based on the existing data. So if your data is good enough, then obviously it's very useful, not even for children, but also for yourself and for the government, for the world. So here's some extra data set that you can take a look at. For example, like Microsoft AI for Earth, they have a lot of data set here that you can use. So AI for Earth. So for example, this is one of the data set from AI for Earth called Damon. Damon is as weather parameters in North America in 1 kilometer grid with monthly and annual summary. So what happened is for the weather data is that they use a grid format. So it's more like rectangular shape format to break down the areas and give you the data, because you cannot measure it the weather in whatever in you don't measure the data in a irregular shape. So then you can download, actually there's the Google Earth Pro. Google Earth Pro is a free app you can download on Google, and you can use that to cover open the shapefile, and you can visualize that. You can visualize the shape of the forest, right? So I don't have it with me right now, but you can just download this, and you will open the shape files, and you can just overlay that with the weather data. So these are the additional data you can get, but I also gave you some of this, like some of the weather data is already given to you. So what your job is just to use this data I provided and train your model. If you want something additional, AI for Earth is you can download them from Azure. So then going to the evaluation criteria, is called Altitude Score. So if you go to this, like I told you, the Azure, the AutoML website, they have these matrices. So this is the altitude score. So you can go through the definition of the altitude score and what MSE means, and what all these other things that you can look at in terms of regression. So then here, if you click on calculation, right? So it will bring you to this website and talk about how do you calculate it. So so this regression problem, we use the altitude score, and again, it's the actual versus predicted. Actual is our answer, and predicted is your answer. And you will count it by 100, then that will be our evaluation criteria. Any questions for data set number 2?
Maybe we jump into number 3 and then see if there's overall questions, if none are popping up right now.
All right. Now let's go to number 3. So number 3 is a retail recommender, and so the data itself is from Instacart. So so it's again, it's not a secret, and so you can see the definition here. So it's the online grocery from Instacart. So it's grocery shopping. So in terms of grocery shopping, you have customer, you have order, you have product. The products are your groceries, right? And then in terms of when you go to a grocery store, you have aisles and you have departments, right? And it's very easy to understand. And so then this is just like the virtual grocery store Instacart data set. Then they have 3 million of the like orders that they have open sourced, and so out of these 3 million products, what I want you to do is that like I want you to tell me whether they have if I give you some of this order history from these customers, and then what you want to do is that tell me whether he will prefer this product, and if he prefer this product, that like in the cart, and whether so then if you go to Amazon or something like that, you probably have a cart, and then in your cart you have 10 items, and then eventually you will check out only 2 items because of interest, budget, or whatever thing. So here's the same thing. Your cart might have 10 items, and tell me which 2 items they have a high possibility of reordering again. So because grocery, like, you don't get to get new grocery every single day, right? So you're likely to buy the same similar thing again, right? So then you need you to predict whether they will reorder this again. So if you find this a little bit hard to begin with, don't worry. I suggest you to go look at this Microsoft Recommender. So in Microsoft Recommender, they have this recommendation system. They have a lot of this models that they have prepared for you, and you can just like go take a look. And this is really good explanation of how do you do the recommendation system. So you don't have to build anything from scratch, but rather you will need to tell me which methodology will you choose, and which model did you choose, and why do you choose, and why does it give good accuracy. So if you look at this Microsoft Recommender, yeah, data preparation, modeling, evaluating, model selection and optimization, and operationalizing. So it's pretty much the end-to-end part of it. Covers everything that you need to do a recommender system. So then you don't have to build a model from scratch to try to recommend something to people. You just use the Microsoft. This Microsoft Recommender is just to tell you the name, even though it's called Microsoft Recommender. It's not. So you look at this GitHub repo. It's Microsoft Recommender. Even though it's called Microsoft Recommender, it's not everything is developed by Microsoft. So I'm not advocating Microsoft or Google or Facebook or whatever platform. It's because they have done a good job in putting together a bunch of like models. So if you ask me to kind of like go do research on what are the available recommended models out there, it will probably take me a few weeks to do, or a few months to do, right? But here they have put together like 30 plus different models. If you see the star here, that means that they are contributed by, invented or contributed by Microsoft. So not everything here is developed by Microsoft, but what they put together is kind of like a quick start repo for you to test your system, test your recommendation. So then again, you will need to, if you need to study all these 30 plus model, it will take you a long time. So but then it will give you some of the quick start to work with. Then you don't have to try to spend time on the model architecture, because in the real business setting, we want to go live with something useful as soon as possible. We are doing a lot of the data science research here. So, but of course, if you say that, hey, my model is excellent, we can and I have high accuracy, and by all means, you can use your own model and own architecture, and there's no restriction. We just want to help you to get started. And finally, that's like the metrics is the, again, F1 score, but to evaluate your model yourself offline, you can also look at this beyond accuracy. So as I said, accuracy is not the most important. So in terms of recommender model, there's some beyond accuracy matrices. And how do you evaluate these matrices? Like for the diversity is talking about you don't want to just recommend the same thing to the person over and over again. You want to have different things in your cart, and that you can recommend to people that they will end up buying. So then just kind of have some of the different items and diversify a little bit, not just like Indian food or Chinese food or American food, um, and just mix of everything. Right? And sorry, DPT is the supplies item that like they, for example, like this person doesn't usually eat like American food, and then you find this American food is very similar to the diet that he has been eating, and you just recommend something for him, and then end up he is buying. So it doesn't necessarily like your friend recommend a movie for you to watch. It doesn't have to be like or sci-fi. For example, you're a good sci-fi friend. You always watch sci-fi movie, but you don't necessarily need to recommend sci-fi for you, because like you want to you're already watching sci-fi movie, right? So why recommend that to you if I know that you are already watching that every single day. So it's something like that, right? Just like some supplies items. So these are the beyond accuracy measure that you can use to evaluate your model. But the end goal though is still to predict whether the customer will buy the product, yes or no, if I give you a card. So and if you have time, you can just like use the Microsoft recommender to implement this like end-to-end workflow, just to make sure that um, just you, and when you have your model, you can quickly like deploy it in a production environment for people to use. So this Microsoft recommender has the examples for you to follow to deploy it in the production. So that's it for the question number 3. Any question?
Any questions at all? This is a safe space to ask before you dive in. I think you're good, Jason. Jason, before we start to wrap up, any last nuggets of wisdom to give our amazing last mile hackers?
Yeah, so we have a Slack channel that's open for discussion, and so for everybody is already joined the Slack channel, and feel free to ask questions, and I'll try to answer them, but I will not give you any code or answer to the hackathon. So if you have any technical challenges, you don't know how to open up Google Colab, or you're getting stuck with downloading the dataset, I will help you with that. Or you need clarification on the dataset, we can do that on the Slack channel. Yeah, so please feel free to use that. And I am in the Pacific time zone, so so then probably I will be able to answer your question. If you're in the East Coast, I will wake up a little bit later. So please be patient on like as we try to host this hackathon, and you're feel free to discuss anything between yourself as well. And you're also welcome to form a team up to 4 people. Every team can be up to 4 people. So if you don't feel like doing it yourself, just find somebody you can partner with. right? So that you are not alone.
Potentially the Slack channel or here in the chat, if you are working on your own or have a group of 2 or 3 and want to pair with others, this chat or potentially the Slack channel could be a great spot to combine groups or individuals if you're looking to partner. Well, thank you so much, Jason, for walking us through each of the hackathon opportunities. I am so excited to see what everybody comes up with over the next couple weeks. As Jason mentioned, please don't hesitate to ask questions along the way. We are here to be your advocates throughout the steps. And Jason, if there's nothing else, to all, have a wonderful evening.
Yeah, that's all I have. Goodbye, everybody.
Awesome. Thank you all.
Thank you all. Have a great day. Bye-bye.
Thank you.
Thank you.